Hello and welcome. I'm Bill Wake. We're working on an Elm interpreter written in Swift. We're up to the point of winning a read-eval print loop, REPL, and we're at the user interface. So we did a little work yesterday. Not very satisfying. But all right, let's see what we got. The problem is text in scroll views seems to be, I don't know if you can say flaky when it's not really fully defined, but that's my word. All right, so I've got text there. We hooked it up just to insert the text we type. And notice the first time we type it, it gave more room to that upper section, which is weird. Let's see. Go away, Siri. The idea is that we'd type our Elm program in the bottom window, hit evaluate, and then see that. Now if I type A, bloop, there it is. And let's put more. All right, a V. Evaluate, hit X. Now we see the V. Still got room. Although I don't know if we can type anymore. Yeah, it's goofy. And the comments show you we've probably been trying a lot of stuff, and that's the case. I don't know. I want to give myself a time box, I guess. So I'd like to get the REPL UI at least kind of minimally functional, and then focus on hooking it up to the interpreter, because we've never hooked anything up to the interpreter other than a test framework. So I know there's going to be some issues there, and I'd really rather focus there today. But so the core thing here is, let's get to that state. There's a log which represents the text that's already been processed, and then there's the input, the text that we're going to process. And we put that Elm REPL at the top. That's sort of the name of the application, I guess you'd say. Where's that running? Let's put this on window 2. Okay, Elm REPL. I'm okay up there. I mean, I have the elements I want. I want a log area and this and a button. All right. I didn't do a lot of research, but I did run across this. There's a bug in Swift UI. At least that's the claim. Okay. If I give it frame main bounds width and height, okay. Or somebody else says give it line limit nil. I don't think the font matters, and frame height ideal infinity. That sounds plausible to me. Let's try that. Okay. Here, extra character, and I'm gonna take out this stuff. We'll bring some of it back. I mean, certainly we'll bring these two back. The scroll view can probably carry those. Okay, and the text is $log. Line limit nil, font large, title we don't care about. Binding conform to string protocol. Oh, text is read only, so we don't need the $. All right, and let's just format this. Okay, we still have the text editor on the bottom. Line limit 10. All right, we'll run. Okay, well, where's your contents? Ends with K. No. What's going on? Well, you would think text log would do that. Well, let's go back a little. Okay, let's see if we're getting anything here. I mean, how could this not work, right? Okay, that's there. Now let's put it in a VStack. Okay, let's give it this border and padding. We'll eventually put this on the outside, but that's okay. Okay, let's see if we're hooked in. Yes. Okay, so something in the scroll view. All right, let's put the scroll view on. You can say dot vertical. Let's turn this back off. It's kind of nice to have it because you can tell where it thinks it is. Okay. Ends with A, starts with E. Okay, that's plausible. I don't think I'm seeing anything too weird. Okay, let's bring in some of this other stuff. Okay, line limit nil. Well, it's acting like it knows this already. Excuse me. All right. There's a little helper going on there. Okay. I would say that's scrolled. We'll add a little more. Should keep adding, and it is. Okay, so it's updating. That's a good thing. All right, let's put the border padding in. That should stretch it. I'm not sure what it does to the scroll bars. We've had some weirdness there. Yeah. Okay, up to Ute. That's all right. We want it to scroll to the bottom, and there seem to be techniques for that. Okay. Now this VStack, putting the frame width there, maybe that would be wise. I'm going to combine. And I don't need the height, because I think I've said my height's infinite. Well, I haven't said it, have I? Trying to get this thing wider. I ran tests. Did I? Yes. Okay. Well, it is wider. Let's give it some padding. I don't know, all this twiddly little stuff. Go 20. I don't know why this padding isn't taken into account here, but let's try and adjust. Yeah, that's much more acceptable. Well, it should be left justified though. Oops. Align the text, huh? Multi-line text argument or alignment. Oh, vstack.leading. Okay, let's see what happens. Nope. Was that multi-line? Well, I don't know that this seemed to do anything. But let's put this on the text. Multi-line arrangement dot leading. I think we had that before somewhere. Grr. Well, you know what we can do? If I do this, we'll get a little picture of where it thinks it is. Oh, I messed up. Int conforms to shape style. Dot frame does not give a view. Border. Oh, we gotta give a color. Interesting. So the green indicates the text, and it's taking just that little bit. Okay, let's add some stuff and see what happens there. Yeah. Okay. Multi-line text. I don't know. There's let's combine this back in. Everybody's saying it's leading, which should be left bound. No. Now we solved this before. Fixed size, frame, alignment, top leading. Well, that seems like a good thing. Isn't that what we did? Alignment, colon, dot, top leading. Or leading, I guess. To be more appropriate, it's the printer's lead between the lines, not leading space. Okay. All right. That is better. So now I got to find out which ones really did the work. Does this have anything to do with it? I hope not, because top leading says align to the top and oh, it is leading, not leading. Yeah, that didn't matter then. And what about this one? That doesn't appear to matter either. Okay. I won't need this for debugging anymore. And then I think the only thing that's down here, well, no, that's lined out too. Okay. Golly, I think I can delete all this. This seems so simple. I don't know how we didn't hit this combination yesterday. It may be that this is doing the work, this main bounds width. But that doesn't explain the scrolling. All right, and I'm not going to worry about that we don't scroll to bottom. All right, so let's run this without the junk in there. Okay, and text. Okay, down to a comma. All right. I think there are defined ways to scroll this thing. Somewhere we ran across something on that, so I'll trust it can be solved. It's a solvable problem and solved for somebody else. All right. Let's see. I've rebooted this. Let's see if this thing kicks in now. That was complaining about a Xcode bug before. And we are seeing something a little weird, like this layout constraint stuff, UI button, bar button. I don't know. I thought we added a little space up top. Yeah. I don't know what that's from, but it's very weird that Swift UI is doing it. We had some similar stuff going on when we were working on the table viewer. The viewer, what did it do? There was some bug in a layout thing, and you dig around long enough, you find Apple's documentation that says there is this bug. Okay, hey, this is working. Okay, what's the blue from? Is that the way it is? Oh, I think that's just the selectable stuff. Yeah, we can change this. Some text. Line. Oh, it paused the updating. Now we can resume it. You can get some handy stuff. So let's see. Can I right click here? Or here? Yeah, I don't see it. There is stuff out there that will like wrap these, whatever you're selecting on. So I'm selecting this, that corresponds to the log. Scroll view, I can select the text and it selects it over here. I think I could edit it. Can I live edit this? Yeah, so the preview is nice when it works. And that's all triggered down here. We have content previews as a preview provider, and it creates a content view, which is our class. The name could probably be better, but all right. And I can zoom this. How about the other way? Even 50 might get it all in there for me. Yeah, pretty close. Okay. It would be nice to work in this a little more. The other thing you can do is like you can put up a content view that's landscape mode or whatever you want to do. So interesting. All right, let's check this in. Isn't it? It's one of these things, like, I don't know, how long did we stumble around yesterday? Probably half an hour to an hour, and come in and 20 minutes later it's all done. Okay, so this is version 1 of REPL UI. All right, and I think we want to Let's make a view folder group. And we'll move this in there. This is our main. We're okay. All right. Imagine if I build again, it'll catch up. Okay. We moved content view to a view group. Alrighty. Well, let's go back to our interpreter. Yeah, so the way it is now, it's sort of assuming somebody else is going to, well, it assumes somebody else is going to do the read, I guess you'd say. The read and parse. So when you parse, you get an expression and you get a symbol table, the context, sort of the predefined system words and things like that. And then definitions you make will add to it or extend it in some sense. We'll get into that later. All right, and then we evaluate. Yeah, and here we're printing. That's not really what we want. Okay, yeah, it would have been good to deal with this sooner. All right, and then the other thing is it's very typical to have a supporting class that acts as it gets called ValueModel often, but it acts as an interface between the view and the core model, which in our case is all the interpreter stuff. Its job is to kind of modify, it's going to coordinate some of the underlying stuff, and it's going to make sure if it needs to translate something to a string, it'll translate it to a string. And then when the user interface goes to use it, hey, it's already just the perfect type, so kind of taking those things in. Now, this to me, we're going to tear some stuff apart, though. The result of evaluating is, it's a string. Expression evaluate. Okay, let's go over there. Okay, so evaluate, you get a context, which is like the current symbols, and the top level class, you never have an actual just expression, so it sort of like, don't do this. But it produces an expression, which I forgot. So this is expression, and then we've got an as string. Now, that's, I don't know, there's something, I mean, we did some custom string convertible stuff. Custom string convertible. I don't know if that's there's also a debug string or something like that. Debug convertible. Okay. So custom string convertible makes your types, gives them a description property, and then people can just call .description. So I think that would be a good first step, that we say expressions, rather than having an as string method, they are custom string convertible. And we may have already done this, but and lots of UI components are happy to print a string. String describing initializers, preferred way to convert. Okay. Yes, print will do it too. Okay. Accessing a type's description property directly or using custom string convertible as generic is discouraged. Accessing directly, huh? So print is okay with it. Well, that's something. Okay, let's see what we can do here. All right, so let's get this thing all updated here. Okay, so REPL and UI. Let's capture what we've accomplished here. So 2021-02-25. I almost can type the year, maybe by March or April. Okay, we're doing this. We'll leave this one. Well, that's sort of redundant. Input box is too tall. That's kind of. I'm not going to worry about that. Let's just say a simple UI with a text field for the previous output and an input field. Well, and an evaluate button. Okay, so that's kind of where we are. It would be nice to scroll. Okay. But I think we're going to make expression be custom string convertible. All right. Okay. Here's interpreter. Let's go to expression. Let's lock that one in. We'll close these for now. Okay, so I would like to be custom string convertible. I am. Oh, okay, we did that part. That should that work? Output.append. Well, here I can get the description. They suggested I don't do that. Print result. I guess that's giving me my console output. And let's see who uses as string. I don't know if I can make. Do I have protected in? I keep forgetting the. I don't think I do. Do I? Or maybe. No. Okay. I guess I can use internal. Hidden from the well, yeah, let's try internal. I don't know if it'll. I'm gonna build. See if these subclasses complain. No. I think they're. Well, who's calling it? Maybe. I mean, these are all error expressions, integer value tests. Will that tell you enough? I guess we'll live with it. Kind of a compromise there. Okay, back to interpreter. All right, this should pass tests, and we'll push it just to kind of lock this in, but I don't think it's doing much. Cool. All right, use expression custom string convertible. I think this may go away in the end. Okay. So I don't think the interpret should be pushing printing the result out. If it produced a string, I would be okay. Okay, so I think what we really want, well, let's go create that view model and see what happens. We'll put that in here. And I don't know, I don't have a good, my only naming convention at this point for them is like interpreter view model. You're always welcome to suggest better. All right. So this thing, the deal is this content view, we want to give it a view model to work with. And this log and the input, well, the input might stay owned by this, but the log is well, I shouldn't say definitely, but I think the log is going to be the thing managed by the view model. It might make sense to let the interpreter do it, but I think we're going to say the interpreter's job is given a bit of code, print out what should be printed, or I'm sorry, return the string that corresponds to what should be printed. Okay, so all right, so I think what we'll do is we'll end up with an init that is going to put the model in place. So I don't know the right way to drive this. I feel like it works best. I think we want to drive it by calling, having the initializer take our interpreter view model. So we're not at the level of testing anything other than manually yet. So I'm going to say there's an init, and it takes a view model of type interpreter view model, which we haven't created yet, and it does some stuff. Okay, and the interpreter view model is just going to be a class. All right, and now this thing, see, it should have a build error at this point. Content view needs an argument. Okay, so oh, you know what? I actually don't even think I have to say the init. But let's get this thing fixed out. So this is going to say interpreter view model. Okay, so it's just going to create one. And I think it'll build. New. Oh, okay, yeah. Okay, so this is the top level thing that gets called when we first start up. I just hit run tests instead of build, but it will build to run the tests. Okay. Right. Now the interpreter view model so I think it's the thing that's got, I don't know what the right word is. It's output so far, maybe. Session. Yeah. Let's try that. Var session of type string starts empty. Okay. And getting these things updating correctly is where I always fall apart. Okay, so we've got an interpreter view model. We really want to make, instead of calling log, we would like log to be correspond to the interpreter view models thing, the session. I don't think I can do that. I have to say like observed object or something. I don't know where I can. Let's see. Swift UI pass observed object. Maybe this is the. And binding, yeah. Okay. Working with the observed object, yes. An observable object and published. There's just so many mechanisms, I just get buried. Okay, we got a view. It's got a list of books. Where's that books come from? Okay, there's some fakes. Add the book row. Main, okay. Publish. Yeah, model, view and model don't directly communicate. They communicate through the view model. Okay. We have bindings. Okay, so on the model, view model say, we're going to say published. Okay. And, well, we'll get to the rest. Published to omit describers before the value changes. Okay. So here, this should be published. You gonna guess it? Yes. Okay. So what publish does is it says we have the string that represents the session. It's a variable that we own. And when somebody changes the string, the published mechanism comes in. So before the actual change, publish goes and tells anybody who's a listener, like, hey, this string is about to change. And so the UI side can use that to invalidate the contents of the text field we're putting it in, basically. And then it knows when everything's done, it should get the latest version. Okay, so I think that published makes sense to me. Books view model. Yeah, we have to tag it observable object. And then somewhere we get a, observed. Okay, so this is an observable object, right? Meaning I contain published things. Content view then says at observed let's get down to the code. No, I don't think we want the binding. Mark this with observed. Telling the book list that it depends on the state of ValueModel. Okay. Now, okay. I think does not have a default value. We use the member initializer on book list. Right. We don't need the initializer if we do it like this. Okay. But the caller is going to have to be more explicit. And we'll need that in our preview. Okay. So we can take it from the preview. It says create a content view where the view model is an interpreter view model. Interpreter view model is here, and it says I'm creating this thing that's an observed object, so you should hook into the listening mechanism. And then in here, this thing says I am observable, so I have a listening mechanism, and whenever somebody changes session, you will get notified. Okay, and I think that's a start. All right, let's run. Nothing should be broken in the run because we haven't done anything with anything really. We still have log referenced and all that. Yeah. Okay. All right. Well, I think we're kind of in the middle of it, but this is a good time for a break. So let's take a couple minutes. I'm just long enough to get a drink of water or something, and come back. And we'll start pushing something in so we can see something going on in that view model. And I think with that, we'll be able to hook it up the rest of the way. So see you in a couple of minutes. Hi, welcome back. All right. So we have some pieces. Let's get something. And we would like something on here for evaluate. Let's see, content view. So we have the button right now. It does this stuff. It plays around with the log that we have. I think what we would like to do is tell the view model basically, I guess it's evaluate. But it's evaluating some text. I mean, it's just going to get the input. All right. So we're not going to do anything real. We're just going to get things hooked up. So I'm imagining there's some sort of function evaluate, and it takes a string, an input of type string. Okay. And it's going to do some stuff. We don't know what stuff. But for now, let's just let's take what it does now. We'll take a version, I guess these two. Should the input be over here too? Maybe it should. Let's do session. I notice at this point we're not doing any interpreter stuff. We're just putting in some things so we can see it operate. I'm thinking maybe the input is over here too. Now this one's different. Don't you love it? Okay. Where's the editing? Yeah, so we need binding. Oh no, where do we pull this up? Right. List. The index of the book in ValueModel. Okay, so we can I feel like I'm still missing something here. So ValueModel.books. I didn't see where they declared that. List ValueModel.books. Yes. Book it. Served object. ValueModel. I know I'm bouncing around. Okay, he has published this. So I guess we could publish that type. Okay, we're going to take this out. And we're going to reset it. So I'm basically copying the code that was in, where is it? Content view. Okay, so append it to the log, append the input. All right, so we really want to call ValueModel.evaluate. I think here. Okay. And then over here, right, so now our evaluate doesn't do anything. We need to link these things in here. So this can be ValueModel dot, what do we call it? Session. Oh, come on. We'll put log for now. We'll do a build. ValueModel. Let me split this. Content view. Okay. And I think I can turn that off. Okay. So over on the left we have session and input. This should become the ValueModel session. I don't know why that's not filling in for me. Okay. Did I hit build or run? Running well when I hit Command B. Okay. Now I'm going to hit run for real. Now at this point, it should only be showing a blank because our session is not real. Let's put a starter in here, and it should show starter now if we've correctly done this. Okay, and let's put more. Well, let's do it the other way around. All right, so I'm going to, when I hit evaluate, I'm going to hit append new line. I'm not taking anything out of that second box anymore. All right, so there's my more. Is it an update thing? Or is it not evaluating? I struggle with this so much. I want my view model. I mean, the thing I worry is it doesn't know, for whatever reason, it's not detecting the change when I do the second one. I mean, let's convince ourselves we are hitting it twice and doing it twice. Yeah, and then okay, let's put the session in there. Okay, hit it 3 times. Evaluate starter, more, starter, more. It's like it didn't really do it the next time. Session.append, new line. Session.append input. Well, I guess this could be like that for what it's worth, but well, we'll put a little bit of more brackets in here just to kind of be really clear what we're getting and what we're not getting. Oh, I cleared input. Okay, let's take this line out. Eventually we will put it back, but I just want to see things growing. I mean, I know intellectually it's really working, but let's see it. Okay. Yeah. All right. So this thing is updating when the session changes. That's a good thing. Now we want to get the input variable tied over to what's being used over here. So now this log, no one's referencing it. And if I build, shouldn't see any complaints. Yeah. Okay, so that's cool. We're going to do the same thing here. We're going to find where this is used. So instead of input here, let's do ViewModel.input. And now I want the clear out. All right. And this should be a two-way street now, or at least a closed loop. I put more in. I can edit it. I evaluate. It goes up here. This one clears out. I can make another line or 2. Evaluate, and those append. Okay, we are approximately where we were, but now we're doing it all out of the view model, which is a good thing. Okay, and I think let's double check that method. View model evaluate. Yeah, so nothing is being done computationally over here. It's all in the view model now. And if it's in the view model, we've got more kind of isolation and control. So if in the view model you want something in the session, we can push it in there. Okay. And we want to do some actual evaluation, and that's what's going to come next. But let me clear this and clear this. So this should be the way we really want it as far as setup. I don't know how evaluate's going to go. It's going to be more complicated, but we can say, hi there, this is, okay. A little bit of swearing, representing what we've done so far. Okay, but that is the behavior we want. And a new line that comes in just appends to the bottom. Cool. Good. Okay, so I guess on our to-do, I don't know, usually I put the to-dos, I try to write things that make sense to a user. It's a little iffy sometimes. This one's very iffy. Introduce view model. Okay, so this is pure programmer talk, I guess. Okay, expression be convertible. Yeah, we did that more or less. Okay. So now we want to connect the interpreter to the UI. Okay. And I think now I can switch to writing some tests. All right. So let's put a group in here for view. And a file in here. And this is interpreter view model tests. As usual. Oh, I know. I got to do it the other way now. We took the trouble to move to trash. Okay, let's see if we can do this properly. New file. Now we've got John Reed's new thing in here. Interpreter view model tests. I guess I could have typed that in front of what he had there. It's in the view folder. That's fine. Underwhelm tests. Okay. He got the import for us, the testable import, declared a test case, and gives us a little starter test that will fail. Okay, cool. All right, so our test. Well, let's take starts empty. I think that's a plausible thing. Okay. I don't know, can I do this? I expect that if you do view model.session, you should get an empty string. And same for input. View model.input empty string. All right, and this test I think will pass. Let's put this over here. Yeah, I mean, we can force a failure if we want to. Okay. Next thing I want to check. Oh boy. It's kind of a leap. All right. So we would like to know that. Oh, I don't know. Do I have an abbreviation for this? Okay. We would like to know that. Interpreting an expression logs it into session. Okay. We're going to be doing this. Sorry about the spam call. I don't know if it comes through the mic or not. Okay, so we're going to create an interpreter model. We're going to, let's set our input to something simple. So ViewModel.input equals good old 42. And if we say evaluate, then we should get 42. Well, no, we should get 42 new line. How do we do these? Maybe these should have this in front and 42 of number. Okay, at the end. And that's, oh, I guess I did that a little backwards. I try and be consistent, at least in a file, but I never, you have this assert equal that's very symmetric, so it doesn't really care whether you put the one or the other first, I don't think. It just says they're not equal. ViewModel.session at the end. Okay, so if you go to our interpreter and you type 42 and say evaluate, it should put a greater than space whatever you put in and the result of the evaluation. And let's take a look at Elm-REPL. Where are you? There we are. Okay, so it gives us the prompt. We don't really need the prompt, but yeah, okay. I think I'm okay with what I've said there. It's a little bit our version of it, but that's okay. And I don't know, that's a little artificial, but maybe we can get a better way to do it. I don't know what the color coding is. Everything's got its own. Okay. Numbers are fuchsia and booleans are aqua or teal. Alrighty. Now, and then I think we also want to know that ViewModel.input should now be empty. All right. And this is totally going to fail. Right. Okay. It only copied our input up to the out session. It certainly didn't put the greater than in, and it certainly didn't put the number in. Okay. Now it gets a little trickier. Okay, but I think I don't need to look at content view, right, to do this. Okay, so what happens? I need to look at the interpreter, I guess. And actually, I don't know, we're going to have to do a little more than. So it's. I would like. Well, we can do the first part, right? We can certainly append that and greater than that, okay, and append the input. That's fine. I mean, that's coming from us. But then we want to append, well, I guess we want another append of new line. And then we want to call, I guess we want to call something that's like interpreter dot evaluate input. So I really want to then say session.append interpreter.evaluate input. All right, and that's not going to build because our interpret, we don't have an interpreter variable, but even if we did, it doesn't have an evaluate input. It has evaluate expression. Okay, so let's build this up. So we got an interpreter is of type interpreter. We'll do that. Okay. This output stuff, it's a little flaky. All right, but anyway, then I don't have interpreter.evaluate with a string. I would like one. Function interpret. Input is a string. And the output is a string. Okay, this does not exist. How do we do that? Well, we're going to have to say let expression equal expression of input. I think. No? How do we get this set up? This is a bit bigger jump than I want, really. Let's just take integer value. Okay. So this thing is an expression. No, who's calling? Where's the interpreter tests? Right, let parser equal parser of input. Expression, this could be AST's abstract syntax tree, which is our expression. Really, this stuff is the stuff we expect. And yeah, it's a bigger step than I want. This is expression. Interpret symbol table. It prints result. I would like that to return it as well. And we'll return result here. Okay, so we're saying the way to do this is you parse the input, you call, you set up a parser, you call it with parser.parse, we don't need an interpreter, we just need to call it interpret expression with, in this case, an empty symbol table. I don't think that's going to be right either, but that's okay. And okay, cannot convert expression of type nothing. All right, interpret is void right now. All right, I'm saying it should produce a string. Result description. Okay, now there's a bunch of people out there calling, well, there's a place or two calling interpret, and now they're going to have to deal with the string coming back. So let's do a build. Value has no evaluate. Did we call it interpret? Yes, we did. I don't know. Evaluate's not bad. Interpreter.evaluate. Yeah. All right. It didn't get very far. We know there's at least one test that is going to have a problem, right? No, it built. Okay, our test should still fail, I think. We're getting there, maybe. Oh, that's what I expected. Call is unused. Okay. How are we doing here? Failed greater 42, 42 colon number is not equal to greater 42, 4. Oh, we got a new line. Do you always get a new line? I don't think you should have an initial new line. Let's go back to our review model. I think this is in fact wrong, and the new line should be down here. Whoa. Okay. Greater input. Well, let's get it working. Let's just, right? One failure. Okay, what's the deal? Oh, now we don't have that in our test. Let's try again. All right, now I'm upset. Greater 42 new line, 42 number is not equal to greater 42, 42 colon. Oh. There are X units that do a nicer job of showing you differences like that. Yay. All right. Hook up interpreter to front end user interface. Okay. Now I want to do some cleaning up. So this really, I think, just to even explain what's going on better, new line, then we append, well, that's not bad. Okay, we got greater append input, interpreter evaluate output, a new line, and that. Okay, so that should be no change. Whoops. Let's run tests. Yay. Okay, now let's tackle interpreter. So who are these people out here? Who calls this? Where's my callers? I'm just going to change it for a moment. See who breaks. Some tests, I think, will. Just one, huh? Interpreter equals interpreter, interpret AST symbol table. Well, all this stuff now is being done by our interpreter. Let's do this. Result equals interpreter.interpret. I'm going to make this expression. Actually, I'm just making it identical to the other one. So parser input expression.parse. result equals interpreter dot interpret. Well, we said evaluate. Oh, we got the symbol table coming in. Interpreter dot evaluate expression. No, that should be input. Take out the quotes. Input. Now, symbol table, we need that coming from somewhere else. Okay. And then let's take, instead of this, let's do result. And I don't know, I'm turning into an actual expected person. All right, this should work. I'm not quite sure about that symbol table. Okay, we created a new one there. I don't think that's the right place, but right. Okay, that was interpreter tests. Interpreter equals interpreter, result equals interpreter dot evaluate. I think I can inline this without upsetting anything. That, okay. Now, nobody's calling this except this. Right, so let's pull out the symbol table. All right, and then we'll reference it here. Okay, because I want that to be alive for the life of the interpreter. Now, who's referencing output? I don't think anybody is. Well, they are down here, but I don't think anybody's calling print anymore. Well, we know nobody's calling myInterpret because I just manually renamed it, so anybody else outside should break, but we don't care about the print, and we don't care about result.description. Well, let's substitute this. It's not quite the same type, but we'll get there. Interpret and context is symbol table. Okay, so the result is evaluate the expression. Okay, so parse it. Cannot convert expression to type. All right, here's where we put description, and this goes away. All right. We want it as simple as possible, but no simpler, in supposedly Einstein's words. It's certainly simpler. But why it's simpler is we took the printing out, and we took the sort of extraneous setting of a side effect out. And we're saying the interpreter's job is not to keep track of the output. The interpreter's job is to say, you give me some input, I tell you what effect it has, string-wise. Okay. Here's your output from it. All right. So we, well, maybe it's strong to call it a refactoring. Well, it is. I think it's okay. Delete dead code in interpreter. Move symbol table up to field, and make test use evaluate. So, yeah, a little shaky to call it a pure refactoring. All right. All right. I think that's a good place to take a break. I definitely feel the tension off my shoulders a bit. We seem to have things hooked up. So, all right, let's take a break, 2 or 3 minutes, and see you then. All right, welcome back. Okay, so at this point, if we've done things right, I'm not quite sure we have the symbol table quite right. There's something going on there. But if we run this thing, each one runs and each time we input it, it's its own complete expression. We don't have anything that carries definitions over in our symbol table. So there may be something funny there, but let's try it. Okay, we'll start with good old 42. All right, our Elm interpreter seems to be working. 3.0 should be a float. All right. True should be a true. We should be able to say if true. Whoops. If. Oh, is it? My eyes aren't very good. All right. It's we got some tuning to do on that. I have to go through this little fun. If true, then 3.0, else 4.0. We predict 3.0. Oh no, I gotta evaluate. If true, then 3.0, else 4.0. Okay, our ifs are working. All right. I think we can say lambda n goes to n. Well, we don't have operators yet, so we can just do that. We get a closure with a symbol table and a lambda n variable. Really, this probably is not what we want to print for this. Okay, let's try it over here. Lambda n goes to n. Yeah, just function a goes to a would be fine. That's more sophisticated than we can do yet. So I'm going to hold off. I'm going to say let's be content for now. All right, but one thing we have to do is turn off that initial auto capitalization, wherever that is. Text editor. Okay, so let's look up Swift text editor. Swift text editor. And cap. Auto capitalization, yes. Okay, so disable autocorrection. That would be nice. All right, so auto capitalization, all one word, lowercase. Auto capitalization dot. Give me some help here. Auto capitalization type. Dot. Just tell me the values. None. Okay. Auto capitalization type. Sorry, wasn't watching well enough. Can I just say dot none? And auto correction. Am I missing? Yeah. Autocorrect. We passed it by. Text editor. Disable autocorrection, true. Let's try our if again. If, yeah, false, then 3, else 4.0 should be legal. I'm gonna hate. That feels like an extra line got in there, doesn't it? If true, then 3, else 4. Oh, I put the extra line in. Yeah. Okay. Yeah, unfortunately, well, I mean, I'm on a Mac in a simulator, so I can hit Command Evaluate or Option Return or something like that. I guess in real use on an iPad, you wouldn't care. It would be nice if somehow I could trigger Evaluate. There may be a way. All right. Let's mark our to-dos because this is a bit of a milestone. Connect the interpreter up. Yes, we've done that. All right. And, this is one of these kind of in the regrets phase. We could have done this right when we had simple integer constants, the first thing we got working. We could have gone ahead and done this then, and there would have been nothing wrong with that. I don't know why I didn't. I mean, I've been very piecewise trying to do one language feature at a time and not just go in and say, okay, let's do the lexer this week and next week we'll do the parser and all that. So it definitely would have been better to get this moving forward sooner on the UI. I mean, it wasn't crazy amounts of hard to hook up or anything, but it's just, we were trying to deliver stuff, and even if our minimal interpreter, up till now you couldn't type in it, so no REPL in our REPL, no read in our REPL. Okay. Okay. So what's the best place to put our next work? Oh, okay. So I guess one choice is the automatically scroll to the end of the input would be nice, even though right now we haven't. I guess I could keep trying to put enough in. 3, 2, 1. I don't know what happens if I do multiples. I'm okay. Yeah, there's something going wrong there. Let's save that for another day too. But if putting in multiple lines of text, evaluate each one as you go. And this is kind of tricky. Again, I don't know what the REPL does. If I say, well, here to, what if I do to, can I do this? No. Okay, I don't have a good way to do it in the REPL maybe. I thought it was backslash. If I say x equals, it knows, hey, you need more lines. But, I don't know. There's some difference in the way we're using it and the way the REPL is. I don't think it's a bad difference. I think it's natural to the way this is going on down here. And this is, well, we're letting you put in a whole thing. So I don't know what will happen here. If I do if true, then 3, else 4, I think that will not work. Well, yeah, internal error. Okay, because it's grammar. We haven't dealt with those new lines yet. Okay. So my top level choices. One choice is, let's work on this REPL user interface and get it all nice and complete, or at least more complete. The second is go back to the language, and I'm leaning that way. I don't know. I don't think this is so interesting per se. I mean, it's like there is a way to make it scroll to the end of the text. We will do it at some point, but if I said, where's the risk in our stuff? It's like, well, we don't really handle much of the language yet. I would like to at least get function definition. I would like this. And then be able to apply it would even be great. Be nice. All right, now let's go over to Elmlang. Elmlang.org. They've reorganized it. Okay, it's still this page though. Syntax. All right, so we're just going down. Comments, yes. Literals, some of them. Manipulation, meaning operators, we don't have yet. Lists, we don't have. Conditionals, we have. We don't have the, you see that they do allow it, multi-line, but we don't have the case statement. And that's got some challenges. Records, functions. Okay, so it would be nice to, like this anonymous function, square equals lambda n goes to n squared. And then pass it to map and call it. Like that's kind of a cool thing. Operators we don't do. Let expressions. I think we have the mechanics in the symbol table to make this work. We don't do these patterns. We certainly don't do type annotations. Applying functions. Yeah, we need to do that. Arithmetic modules, types. Yeah, I think function calls, well, the whole stuff around function definition and function calls is probably the best place to do next. It's pretty much, I mean, it's a functional language, right? So that's pretty much the heart of what's going on. We let you define square, but we don't have a call mechanism. Like, how would you know you're getting called? I mean, just from a grammar point of view, it's kind of crazy. If you saw, well, we don't do parentheses yet, so that would be a good thing to do. Because we'd like to pass in something parenthesized or call it. We could say lambda n goes to n parentheses 3, and it should be pass in 3, evaluate it. 3, 3 is the result. Let's see. So I got to get my head back in compiler land then. All right. So let's move function stuff up. Weird. Okay. And I think even before that, we're going to do parentheses in expressions. I don't think this is trivial, grammar-wise. I would like, normally you have expression goes to, and then one of the factors is parenthesized expression. I don't know if that's really the whole story here, right? Like here's, well, do you pass AB as a parameterized list? I don't know. Another one, parentheses around an operator, make a function out of it. So you can use it as a prefix rather than an infix operator. Well, let's start simple. As pairs of small brains have to do. Okay, so we have expression, and let's see, where's our parse for that? Parser. Okay, so our parser, basically it looks at that first token and decides what rule to apply. Right now, only ints, floats, and uppercase names are in expressions. Really, lambdas should be an expression, I think. But we'll save that one for a moment. But what I would like to have is parenthesis, left parenthesis. Okay. And if we go into our lexer, again, it's a similar kind of mechanism. It switches on the character, but notice there's no parentheses yet. Okay, so let's put those before the real operators. Okay, so let's get to a test. And these kind of end up pretty simple. Like so simple, maybe I should be combining them. Left parenthesis. I say parend. Hopefully that's legal to, sounds right to you all. I'm making up that there's a left parend. And I'm going to, whoops. Well, we can do one at a time. All right, token. I'm going to add this other one while I'm in here. I don't know. I guess I don't want to abide by my principles fully for some reason. All right, so this should compile and fail. Yep, and we got unexpected character, not left parend. Elixir. Yeah. Okay. Left parend. We'll put them down near equal operator. Okay. Skip next character, return token dot left parend, and pass. Yeah, I probably should just put both tests in at once. You know, it's kind of would have been just as fast. Right parend, and the token is this one. Fails. We got the character, but we don't have the case statement for it. And this. Oh, didn't put the method in. Okay, let's do this. Oh, I get a surprise. Okay. Right parend is not equal to left parend. Oh, yeah. Excuse me. All right. Yeah, on the one hand, it's like, oh, I can do this in one step, and even breaking it down into small pieces mess it up. All right, so add tokens for left and right parentheses. Okay, while I'm here, I'm seeing there's a definite pattern, so much that I just copy the function, but this thing is basically the only difference between these methods is the return type of the token. So this is a single character token. Let's make a function for that. Let's extract it. I don't know if refactor single character token. Okay, and I want an argument that's the I would like you to tell me what you want. So this should be token.newLine should be passed in, and this should be here. Okay, should pass. Only newLine's doing it so far. Okay, so this should be, well, you need this. Well, we're going to inline it. Okay, let's inline it. Well, probably the whole thing, right? So where's newLine? Single character token newLine. Okay. This one's too complicated, but this one, well, I think equals can do it. Thanks. Okay. All right, this should work, and then we got some dead code to get rid of. And I think I'll pull this down. There were kind of some helpers at the bottom that were more like manipulating. Yeah, so this is an example. I think he's at least, I think that's good. Yeah, and then these ones that are duplicates. So newLine is gone, left parent is gone, right parent is gone, equals is gone, lambda is gone. Okay, and again, the driver was just the identical shape of those methods. We may have to revisit it, like if there's a double equals or something like that. We can't do this anymore, but at least for the ones where it works, that's good. I know we have commas and other single character stuff coming, so it's okay. Let's make sure that all works. Okay. We refactor, we extracted a single character token and deleted dead code. All right, so I think our token's okay now. Let's close this. Probably should close all these. Try and start over once in a while. All right, so now we need the parser and the parser itself. Okay. Oh, I hate that. Parser tests. Double click. Okay. All right, so The parser, what should it do when it sees a left parenthesis? Well, it should do a parenthesized expression. So let's make a test. And I'll just start at the bottom. Function test parenthesized expression and check successful parse. The input is well, let's mix it up a little. Two of these. Okay, and the value we expect, I think, is just the integer. So let's find an integer. So parentheses really, they act as structuring mechanisms, but they don't normally put any semantics in there. We'll see what goes on. I'm still a little worried about these kind of things, but it may be that they only come in a context. Well, no, here's an expression, parenthesis 3 comma 4. So we'll have to deal with something at some point, not right now. All right, this should fail. Should be some sort of error message. I hit position 1, I think, column 1. Excuse me. Unexpected input. Okay. Right. So we need to parse it. Excuse me. We're shifting weather here and I'm feeling it. Okay. I guess you can go, well, they're all expressions, so there's no real benefit one way or the other, I guess. All right, so here's function parenthesized expression. And it's going to return an expression. All right. And when we come in here, so the grammar is left parenthesis expression. Right parenthesis. I'm seeing a flaw in my thinking already here. Okay. We'll get through this test. And we want to get next token, so we got to consume the left parenthesis. And then we're going to match the expression. Okay, and at the end we're going to return expression. Okay. And then we're going to require, and that's just the token we want, which is token.writeParent. And notice require consumes it as well. Okay, and it can fail. So we got to put a try catch around all this. Once again, the error handling becomes the story. So we're kind of in the same boat as if expression there. Do catch around all this. And I think we can just catch anything and return an error expression. Expression. That doesn't exist. Well, and this is, let's make one that's, we'll come back and really do it. I'm trying to get this path right, so I'm not going to try and play around on that one. So get your next token, parse the expression, require right paren, return expression. Okay, I think with our test case, right away we're going to see the problem. Something should blow up. We'll see. Yeah. I don't know if you've played with grammars enough, you probably know what it is, but we handle the first parenthesis, but when we call expression, we left expression up here. We only expect one of these three things. We don't allow for a left parenthesis. So I'm going to simplify the test case and then fix the error. All right, so this should pass because we consume our parenthesis. We call expression with 999 in place. It says, "Oh yeah, I'd be happy to match that for you," and then returns, and we take out the right parenthesis, and we're ready to go. All right. Let's move this around a little. All right, clearly expression, this thing should be near expression, so let's move it back up. I don't think it's wrong to have a parenthesized expression method. It's just not the right way to go in about it, I guess. All right, so what I want to do is move this up and move this down. Okay, so I'm now saying if you see any of these tokens, including left parenthesis, it's time to parse an expression. And then the expression, well, now it's looking at the token type. If it sees if it sees a left parenthesis, we want to handle that separately. So token.leftParen. Okay. Now we want to do parenthesized expression. Okay. And so you see we've got expression, and I'm going to capture some of the grammar here. Expression goes to int or float or lowercase name or uppercase name or parenthesized expression. Okay, and so we're covering that case now. We call parenthesized expression. I could inline all this, but it consumes that parenthesis, calls expression recursively, okay, and then does these things. All right, now the other thing we got going, this normally this would actually be called factor. So is that right? Yeah, so when you think about the levels of arguments or operators, like times has high precedence. So you normally have the pieces of a times that are factors. That's the things you're multiplying together. And integer, float, lowercase name, uppercase name, and parenthesized expression are all valid factors. But I don't know if we need to pull that at this point. All right. Notice we're not going to do a right paren up here. That's not a legal thing. Okay. So now let me expand this. I think I've got it working for nested parentheses. And if you don't, with these recursive things, like, it's easy to get off track. But let's make it kind of ridiculous. I'll put 4 in. 2, you could say, oh, you sort of worked around it. But 4, like, by this time, you're definitely in the recursion. So just to kind of really lock in that these things work. Okay. And let's do the error case now. So test parenthesized expression gets error if right parend is missing. Okay. And we have our check failed parse for that. All right. So we needed an expression 3.0. I'm only going to put 1 right parend. And we expect to get missing right parenthesis. All right, which does not exist. Missing missing a right parenthesis. Okay. And this test should fail. Oh, it's 3 o'clock. Sorry, I didn't even notice it was getting close to the end. I used to have a buzzer that would go off, but I don't have that anymore. All right, well, that'll be a good place to pick up next time. So next time is Tuesday, 1 to 3 p.m. Eastern Time. We'll pick up with failing parentheses. And thanks for joining me. Hope to see you again in the future. Take care. Bye-bye.